So here is a quick review of some common misconceptions that you may find or that you may use. You're not going to find them very often in the literature, but you may find it in talking to other people, or you may find that other people actually have this interpretation, and so you want to make sure that you realize it is incorrect. Some people, for instance, believe that all data of a data set are within a standard deviation of the mean. This is confusing the standard deviation with the range. Remember, all data of a data set are within the range from the minimum and the maximum, but that has nothing to do with the standard deviation. So this is definitely incorrect. Now, some people have heard something else that we'll explain in a minute, and they end up claiming that 95% of the data are within one standard deviation. They realize that standard deviation does not cover all the data, and they say that that is true. Well, that's not true either. So if you hear something like that, keep in mind, no, it is not true. Some people are getting very close to a correct interpretation and saying that 66% of the data are within one standard deviation of the mean. We are now very close to the truth of the matter, but even this one is not correct. Okay, why? Where are all these interpretations coming from, and what is the correct one? Well, the correct interpretation of the standard deviation turns out to be in the context of bell-shaped data. Now, we have not seen this yet. We're going to see it later on, and not even very much in depth, but probably you know what I'm talking about because you have seen it in the past. Okay, so let's say you have a data set that produces this kind of bar graph. We have not talked about bar graphs either, but I'm relying on your previous knowledge about it. And notice that this bar graph, that does look like a skyscraper in the United States somewhere, doesn't it? But no, I'm thinking of this as a bar graph. And this one has a shape that looks like the bell curve, right? Now, if data are of this sort, then it is true that approximately 66% of the data are within one standard deviation of the mean. What does that mean? Well, if it has a bell-shaped, if the data are distributed on a bell shape, that means that the mean is actually right in the middle. It's at the peak of the distribution, at the highest bar. And if we measure one standard deviation away from that, on either side of the mean, what happens is that if you look at the data which are enclosed in that interval, all those data cover about 66% of the whole data set. But again, remember, even this one is an approximation. Using the same argument, it is possible to prove that approximately 95% of the data are within two standard deviations, not one but two. However, keep in mind, this is only true if the data have that spatial distribution. In other situations, those percentages may be quite different. So you want to make sure to not extend that kind of interpretation to all situations. So be careful with interpretation. Standard deviation is not a good descriptive measure. It's not good to interpret intuitively. Might as well use range or interquartile range. Now, how should we then use the standard deviation? Well, we're not going to use it that much now. As I said, it's mostly for inferential work. Okay, so for now, what we're going to do is we're going to identify where it is reported. We're going to use it for superficial comparisons, is for comparing two data sets for the same variable, and one has a bigger standard deviation. We can conclude that the data are more variable in that data set. But most of all, we're going to wait for inferential applications later. So for now, just take note of the fact that these things exist. Okay, is there a better way to describe variability given all the problems with the standard deviation? Yes, that has to do with graphs, and so we're going to wait until we look at graphs. One last thing to remember, you may want to watch out for two things that are often reported in the literature. One is the standard error, often denoted as E, and that's simply the standard deviation divided by the square root of n. Guess what? This is also used in inferential work. And the other one that you may see is something called the coefficient of variation of C, or CV. This is obtained by dividing the standard deviation by the mean, and basically gives you a ratio of how much variability do we have with respect to the size of the data. If the standard deviation is big with respect to the data, that means you have a lot of variability. If it's small, then it means that you don't have really a lot of variability for the numbers you're computing. But that's it for now. Just keep in mind to control or to identify these standard deviations where you see them, and not much more.